Hello dear students, all of you welcome to Vidyayana classes. Today we will discuss some expected board questions on tangent and normal to a curve. First question, so that the tangent to the curve x is equal to a into t minus sin t, y is equal to 80 into 1 plus cos t at t is equal to pi by 2 has a slope 1 minus pi by 2. Easy question. The curve is given by x is equal to a into t minus sin t and y is equal to 80 into 1 plus cos t. Differentiating both the sides x and y with respect to t, which implies as dx by dt is equal to a into 1 minus cos t, where a is a constant, and dy by dt is equal to a into, in the form of u into v, 1 plus cos t, derivative t with respect to t is 1, plus t into derivative 1 0 cos t is minus sin t, which is same as a into 1 plus cos t minus t into sin t. Clear? Clear? Okay. dy by dx is equal to dy by dt whole divided by dx by dt. dy by dt is given by a into 1 plus cos t minus t into sin t whole divided by dx by dt 1 minus cos t. Clear? dy by dt, this value dx by dt is a into 1 minus cos t. A cancel, which is equal to 1 plus cos t minus t sin t whole divided by 1 minus cos t is the slope of tangent to the curve at any point. Here dx represents slope of the tangent to the curve at any point. We have to find out the slope of the tangent at t is equal to pi by 2. dy by dx t is equal to pi by 2, which represents slope of the tangent to the curve at t is equal to pi by 2, which is equal to 1 plus cos pi by 2 minus t is equal to pi by 2 sin t, that is sin pi by 2 whole divided by 1 minus cos pi by 2, which is equal to cos pi by 2 is 0, sin pi by 2 is 1. 1 plus 0 minus pi by 2, sin pi by 2 is 1, 1 minus 0, which is equal to 1 minus pi by 2. Here, therefore, slope of the tangent to the curve at t is equal to pi by 2 is 1 minus pi by 2. Clear? Find the point or points on the curve y square minus s square plus 2x minus 1 equal to 0 where the tangent is parallel to x axis. The given curve y square minus s square plus 2x minus 1 equal to 0. Differentiating both sides with respect to x implies 2y dy by dx minus 2x plus 2 minus 0 is equal to 0. Clear? Derivative of y square with respect to x is 2y dy dx, derivative of s square 2x, derivative 2x is 2, derivative constant 0 and derivative of 0 is 0. Y dy by dx is equal to x minus 1. Clear? 2 cancel, which implies this y dy dx x minus 1. dy by dx is equal to x minus 1 divided by y. Is the slope of tangent to the curve at any point. Given tangent is parallel to x axis. Given tangent is parallel to x axis, which implies slope of tangent is equal to slope of x axis. Tangent is a line. Two lines are parallel, slopes are equal, which implies a slope of tangent x minus 1 divided by y. Slope of x axis, that is 0. X minus 1 is equal to 0, x is equal to 1. For x is equal to 1, implies equation 1 implies y square minus 1 square plus 2 minus 1 is equal to 0, which implies y square is equal to 0, that is y equal to 0. Clear? Therefore, 1 0 is the point on the curve where tangent is parallel to x axis. Clear? Clear? Find the angle of intersection of two curves y is equal to 5 to the x and y is equal to 2 to the x. Angle between two curves. Y is equal to 5 to the x, y is equal to 2 to the x. Angle between two curves is defined by the angle between two tangents at the point of intersection. P is the point of intersection of the two curves. Angle between two curves is defined by the angle between two tangents at the point of intersection of two curves. Tangent 1 and tangent 2. It is the angle between two curves, that means two tangents. Tangent 1, tangent 2. Find the angle of intersection of two curves y is equal to 5 to the x and y is equal to 2 to the x. Answer: y is equal to 5 to the x, y is equal to 2 to the x, which implies 5 to the x is equal to 2 to the x, which implies x is equal to 0. For x equal to 0, 5 to the x is equal to 2 to the x. For x is equal to 0, implies y is equal to 1. 5 to the 0 or 2 to the 0 is 1. Implies 0, 1 is the point of intersection of two curves. So the coordinate of P are x equal to 0, y is equal to 1, 0, 1. We have to find out the angle between two curves. That means angle between two tangents at the point of intersection of two curves. Let theta be the angle between two curves y is equal to 5 to the x and y is equal to 2 to the x. Clear? Y is equal to 5 to the x. Differentiating y with respect to x, dy by dx is equal to 5 to the x into ln 5, which implies dy by dx, it is the slope of the tangent to the curve at any point. Slope of the tangent at P, that is 0, 1, is equal to 5 to the 0, 1 ln 5, which is equal to m1c. Slope of the tangent to the curve y equal to 5 to the x at the point 0, 1 is ln 5. Y is equal to 2 to the x. Differentiating with respect to x, dy by dx is equal to 2 to the x into ln 2. Is the slope of the tangent to the curve at any point on the curve y is equal to 2 to the x, which implies dy dx at 0, 1. For x equal to 0, 2 to the 0 is 1 ln 2, which is equal to m2c. is the slope of the tangent to the curve y is equal to 2 to the x at 0, 1. Theta is the angle between two curves, that is angle between two tangents at the point of intersection. Tan theta is equal to plus or minus angle between two tangents, that means angle between two lines, which is equal to tan theta is equal to plus or minus m1 minus m2 whole divided by 1 plus m1 into m2, which is same as modulus of m1 minus m2 divided by 1 plus m1 into m2. Since x mod is equal to x if x is greater than equal to 0, minus x if x is less than 0. If it is positive or 0, the result is plus. If it is negative, the result is minus of this, which is equal to m1 means ln5, m2 means ln2 whole divided by 1 plus ln5 into ln2, which is equal to mod of ln log m minus log n, that is log m by n, 5 by 2 whole divided by 1 plus ln 5 into ln 2. Tan theta is equal to this. Theta is equal to tan inverse mod of ln 5 by 2 whole divided by 1 plus ln 5 into ln 2 is the angle between two curves. Is the angle between two curves. Clear? Find the angle between angle of intersection of two curves. Angle between two curves is defined as the angle between two tangents at the point of intersection of two curves. Clear? Next question. Find the equation of the normal to the curve given by x is equal to 3 cos theta minus cos q theta, y is equal to 3 sin theta minus sin q theta at theta is equal to pi by 4. We have to find out the equation of a normal. Answer: x is equal to 3 cos theta minus cos q theta. Differentiating both the sides with respect to x. Differentiating x with respect to theta implies dx by d theta is equal to minus 3 sin theta minus 3 cos square theta. Derivative cos theta is minus sin theta minus minus plus sin theta. Y is given by 3 sin theta minus sin q theta. Differentiating y with respect to theta. dy by d theta is equal to 3 cos theta minus 3 sin square theta, and the derivative sin theta is cos theta. Clear? Now dy by dx is equal to dy by d theta divided by dx by d theta, which is equal to 3 cos theta minus 3 sin square theta into cos theta whole divided by dx by d theta minus 3 sin theta plus 3 cos square theta into sin theta. Clear? Taking 3 cos theta as a common, dy by d theta dx is equal to 3 cos theta whole into 1 minus sin square theta whole divided by minus 3 sin theta whole into 1 minus cos square theta. Clear? Clear? Okay. 3 3 cancel, which is equal to cos of theta into cos square theta minus sin theta into sin square theta, which is equal to minus of cos cube theta divided by sin cube theta, which is equal to minus of cot cube theta. Clear? Is the slope of tangent to the curve at any point. Is the slope of tangent to the curve at any point. At theta is equal to pi by 4, dy by dx is equal to minus cot 45 degree 1 minus 1 is the slope of tangent to the curve at theta is equal to pi by 4. Is the slope of the tangent to the curve at theta is equal to pi by 4, which implies as 1 is the slope of normal to the curve at theta is equal to pi by 4. Slope of normal is the negative reciprocal of the slope of the tangent. Since the slope of tangent is minus 1, slope of normal is 1. At theta is equal to pi by 4, x is equal to, at theta is equal to pi by 4, x is equal to 3 cos of 45 degree 1 by root 2 sin 3 cos 45 degree cos of 45 degree to the power 3, that means 1 by 2 root 2. Clear? Which is equal to 2 root 2, 6 minus 1, that is 5. Y is equal to 3 sin 45 degree, 3 into 1 by root 2. minus sin 45t to the power 3, that means 1 by 2 root 2, which is equal to 5 divided by 2 root 2. xy which is equal to x1 y1 is equal to 5 by 2 root 2, 5 by 2 root 2. Clear? Find the equation of a normal. Equation of a normal. Y minus y1 negative reciprocal of slope of a tangent dx x is equal to x1, y is equal to y1, x minus x1, which implies this. Y minus y1, y1 is 5 divided by 2 root 2. Slope of the normal, it is the slope of the normal, that is 1, into x minus x1. x1 means 5 divided by 2 root 2, which implies this y minus 5 by 2 root 2 is equal to x minus 5 by 2 root 2. 5 by 2 root 2, 5 by 2 root 2 cancel, that is equal to y is equal to x. Clear? Okay. Therefore, y is equal to x is the equation of normal to the curve at theta is equal to pi by 4. Is the answer. Clear? Next question. Tangents are drawn from origin to the curve y equal to sin x. Prove that their point of contact lie on the curve s square y square is equal to s square minus y square. Answer. The given curve is y equal to sin x. Tangents are drawn from origin. It is the tangent drawn from origin. Y is equal to sin x. Let x1, y1 be the point of contact. Tangents are drawn from origin to the curve y equal to sin x. Prove that their point of contact lie on the curve s square y square is equal to s square minus y square. It is the graph of y is equal to sin x. Let x1, y1 be the point of contact. Let x1, y1 or a pair be the point of contact of tangent and y is equal to sin x. Y equal to sin x is the given curve. Differentiating with respect to x, which implies this dy dx is equal to cos x, is the slope of tangent to the curve at any point, which implies dA by dx x1 y1 represent sin, that is cos x1 is the slope of tangent to the curve at x1 y1 order pair. Cos x1 is the slope of tangent to the curve at x1 y1. Equation of tangent to the curve at x1 y1 order pair. Y minus y1 dA by dx x1 y1 whole into x minus x1 is the equation of a tangent to the curve at x1 y1, which implies y minus y1 dA dx, that means slope of the tangent at the point x1 y1 is cos x1 whole into x minus x1 is the equation tangent, is the equation of a tangent. Tangents are drawn passes through origin. Tangent passes through origin, implies the tangent passes through origin. So, which implies 0 minus y1 is equal to cos x1. X will be 0, y will be 0. Since the tangent passes through origin, 0 minus x1, which implies y1 is equal to x1 cos x1. Squaring both sides, which implies y1 square is equal to x1 square cos square x1. Here, squaring both the sides, which is equal to x1 square 1 minus sin square x1, which is equal to x1 square minus x1 square into sin x1 square. Clear? Which implies y1 square is equal to x1 square minus x1 square y1 square. Since x1 y1 order pair lies on y is equal to sin x, implies since this point lies on the curve, the point will satisfy the equation y1 is equal to sin x1. Sin x1 is equal to y1. So this value will be x1 square into y1 square. x1 square minus y1 square is equal to x1 square into y1 square. Clear? This implies x1 y1 order pair lies on the curve s square minus y square is equal to s square into y square. The curve passes through this point. So that the result will be x1 square minus y1 square is equal to x1 square into y1 square. Or we can say this implies x1 y1 lies on the curve s square minus y square is equal to s square y square. Hence proved. Hence proved. Clear? Clear? Next question. So that the length of the portion of the tangent to x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. Intercepted between the axes is a constant. Answer. The given curve is x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. Differentiating both sides with respect to x. Equation 1 implies 2 by 3 x to the power minus 1 by 3. 2 by 3 y to the power minus 1 by 3 into dy by dx is equal to 0 since a is a constant. 2 by 3 cancelled. x to the power minus 1 by 3 plus y to the power minus 1 by 3 is equal to 0. Since 0 by 2 by 3 is equal to 0. dy by dx is equal to negative of x to the power 1 by 3 divided by y to the power minus 1 by 3. Clear? Which is same as minus y to the power 1 by 3 divided by x to the power 1 by 3. Either slope of tangent to the curve at any point which implies dx at x1 y1 is equal to minus y1 to the power 1 by 3 divided by x1 to the power 1 by 3 is the slope of tangent to the curve at x1 y1. Dx represents slope of the tangent to the curve at any point, but dx at x1 y1 which is y1 to the power minus of y1 to the power 1 by 3 divided by x1 to the power 1 by 3. Clear? equation of tangent at x1 y1. Equation tangent to the curve at x1 y1. Y minus y1 dy by dx x1 y1, that is slope of the tangent to the curve at x1 y1, whole into x minus x1. That implies y minus y1 dx at x1 y1. Dx at x1 y1 is negative y1 to the power 1 by 3 divided by x1 to the power 1 by 3. Clear? It is the slope of the tangent to the curve at x1 y1 into x minus x1. Any doubt? Okay. We have to find out the length of the portion of the tangent. It is the equation of a tangent. Length of the portion of the tangent to the curve intersected between the axes. It is P x1 y1. It is the graph of the curve x to the 2 by 3 plus y to the 2 by 3 is equal to a to the power 2 by 3. And it is the tangent to the curve. X intercept. Putting y equal to 0, we will get the x intercept. Put y equal to 0, it is equation 2. Equation 2 implies y minus y equal to 0, that means 0 minus y1 is equal to minus y1 to the power 1 by 3 divided by x1 to the power 1 by 3 whole into x minus x1, which implies y1 is equal to y1 to the power 1 by 3 divided by x1 to the power 1 by 3 x minus x1, which implies x minus x1 is equal to x1 to the power 1 by 3 y1 to the power 1 minus 1 by 3, that is x1 to the power 1 by 3, 1 minus 1 by 3, that is y1 to the power 2 by 3, which is equal to, which implies x is equal to x1 plus x1 to the power 1 by 3 y1 to the power 2 by 3, which implies x is equal to x1 to the power 1 by 3 x1 to the power 1 by 3 taking common, it gives x1 to the power 2 by 3 plus y1 to the power 2 by 3, which is equal to x1 to the power 1 by 3 a to the power 2 by 3. Since x1, y1 lies on the curve. The curve is x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. x1, y1 lies on x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. Implies x1 to the power 2 by 3, y1 to the power 2 by 3 is equal to a to the power 2 by 3. So x1 to the power 2 by 3 plus y1 to the power 2 by 3 is equal to a to the power 2 by 3. Y-intercept. Y-intercept can be obtained putting x equal to 0 in the equation of a tangent. Put x is equal to 0, equation 2 implies y minus y1 is equal to minus y1 to the power 1 by 3 divided by x1 to the power 1 by 3, 0 minus x1. Putting x equal to 0, we will get the y-intercept. x1 to the power 1 by 3, a to the power 2 by 3 is the x-intercept. Which is equal to y1 to the power 1 by 3, x1 to the power 2 by 3. x1 to the power 1 by 3, here it is x1, cancelled, x1 to the power 1 by 3 cancelled, it gives x1 to the power 2 by 3. Which implies y is equal to y1 plus y1 to the power 1 by 3, x1 to the power 2 by 3. y1 to the power 1 by 3 taking common, it gives x1 to the power 2 by 3 plus y1 to the power 2 by 3, which is equal to y1 to the power 1 by 3, a to the power 2 by 3 is the y-intercept. Y-intercept is the y-intercept. That means the tangent meet x-axis at A and meet y-axis at B. The coordinate of A x-intercept, that is x1 to the power 1 by 3, a to the power 2 by 3, s coordinate. On x-axis y coordinate is 0 and the y coordinate, the coordinate of B, s coordinate is 0, y coordinate is y1 to the power 1 by 3, a to the power 2 by 3. We have to find out the portion of the tangent intersected between the axes. Axis means x-axis and y-axis. AB is the portion of the tangent intersected between the axes. What of AB? That means distance between A and B is equal to square root of x1 to the power 1 by 3, a to the power 2 by 3 x1 minus x2 that is 0 whole square plus 0 minus y1 to the power 1 by 3 a to the power 2 by 3 whole square. Mod of AB represent the portion of the tangent to the portion of the tangent intercepted between the coordinate axes, which is equal to x1 square root of x1 to the power 2 by 3 a to the power 4 by 3 plus y1 to the power 2 by 3 a to the power 4 by 3. Clear? Clear? Okay. Taking a to the power 4 by 3 as a common, a to the power 4 by 3, it gives x1 to the power 2 by 3 plus a to the power 2 by 3. y1 to the power 2 by 3, which is equal to a to the power 4 by 3 into a to the power 2 by 3. x1, y1 lies on the curve. So, x1 to the power 2 by 3 plus y1 to the power 2 by 3 is equal to a to the 2 by 3 square root, which is equal to a to the power 6 by 3, that is a square, which is equal to a is a constant. Is a constant. Hence, length of the portion of the tangent to the curve intercepted between the axes is a constant. Hence, it is proved. Clear?